Does it multiple? Oh, it's
Yeah. There's the 2 over here. She died at 8. Sure.
Oh,
Sure, okay.
there's another phone that can show it's so much a card. Doesn't matter, it's just one. Dude, there's one in the site. Are you not reading the questions that he's asking?
I don't know if there's a question there.
Well,
Balance the following chemical equation. That doesn't sound like a question.
Yeah, the question is the statement.
The question is the statement.
Yeah.
Sure. But I think you gave it to you. Maybe not. Let me check. No, because I got your test and everything too here. That's yours.
No.
You go.
We've been, no.
No. Don't you have to write down about the growers?
I'm not kidding.
I don't know what that means. You don't have to write. It's not what I said.
Beautiful kid.
We can just get rid of the oxygen and then there's no oxygen. Nothing on both sides. I'm done.
I don't know that you can just make up rules as you go.
It's fine.
Did you get a balance?
Yeah, because there's no oxygen in one. I don't know what to do. I don't think he's gonna take that for
Wait, so.
Well, did you check how many oxygens are on each side?
But like, wouldn't you want to balance the oxygen first?
Do I add this?
No,
Or
you
no,
both
it's
like
all
it.
For you, chief.
So I accept it.
6 and 8 is 14, right?
What is the period? Alright.
9.
So.
So.
That's not 14.
No, that's not 14. I'm agreeing with you 100% there.
Oh, so you still have, oh, wait. What?
7?
So wait, how many oxygens
Oh,
would there be?
Yeah, that's what we're talking about, oxygen.
I did it.
Wait, do I have to? Attention to 14.
You're right, it doesn't.
Smart cadence. It's such a bad word.
So again, in the end, hang on a minute. Which side needs more oxygen? Okay, now, here's a little piece of advice. Because this is just CO. We can put different numbers in front of there. And the nice part is, because of the C right here, we'll be able to balance it out pretty easily. So let's figure out what we would have to get here to get to that 14 oxygens. So, no, because 9 and 4 is what? Phosphorus, okay, so let's put 5 there. What?
That's it. No.
I thought it was
Well,
How do you get 16 oxygen?
because this gets in
update down there.
What gets?
when you put it
Yeah.
here, this is 3.
Sure doesn't quite yet.
So not everything's balanced
It's
except
a
for
little
this, and I
messy,
can balance this.
Okay, wait.
But
Well,
then once
that's
you balance
me.
that,
I don't care what it looks like until the very end.
Okay, then let's
Okay, I
let's
did.
do it.
Can I mess up 1 second?
I put 3.
Okay. I couldn't tell if that was a 2 or a 3. No, you're fine. Thank you.
So,
Put the 0
oxygen
and 0 with the O back.
oxygen, that'd be.
I undeleted it.
16.
He undeleted it.
When When you get to this point, it's not.
Oh, found it.
One side.
Are you confused?
You haven't messed
So,
up. You
carbon,
just don't have
carbon,
no oxygen on one side.
the balance if you add 6, hear me out.
Now, here's what I'm gonna tell you.
6, hear me out.
You got two choices.
This turns into 16, carbon,
Which
you
one
add
is the better choice?
6, you add 6 here.
Okay, but also look at this. If I put a nine. So sassy with it.
Why would you put 7?
So hypothetically, if I wanted to, I could just, I could put a 21
Plus
right
nine,
there,
plus nine.
have 21
Yes.
carbons and 21 oxygen.
Oh, so 7.
21.
Oh, yeah, 7.
With the oxygen.
Well, that's the thing.
7, 16.
So there's only
Wait,
one
how
way
many
to get
oxygens did
it.
you get?
You got plus 16.
16. Nope, not big enough. I don't wanna give you two of them.
Alright, so we rewrite.
Yeah, I'm done.
Now you recheck all your numbers. Alright?
This one is difficult, ladies and gentlemen, because just when you think you've got everything balanced,
I got it.
you don't.
I don't.
You don't. There's one thing, well, I shouldn't say that, but if you've got most of the things balanced and then you're like, oh, I'm going to do that part where I just ignore the oxygen until the end, the oxygen's going to kick you in the butt in the end.
I think I got it.
We should have just
Well, how's it
Well,
going with all the
we
rules for
decided
the
to do it.
table over there? Someone had to make those up. Why can't I make this up?
Because it's not really about making the rules up, it's about finding the rules and stating them.
Right, the picture.
Yes.
Nope.
Period, because it's statement.
First of all, you have 6 carbons here, and you have 7 here. That can't be.
Oh, well, yeah, I wrote this wrong.
Oh, well, then is this correct? No.
Can write it first.
No.
How do you read it?
Why?
How do you write
Because that doesn't balance out.
3, 3.
Double check everything.
7, 7, 3, 3.
How many oxygens here?
6.
How many here? That's 14 in my book. Okay.
Oh, shoot. Yeah. I think
Ethan, what you
you forgot about more than 7.
Oh, nothing much.
A little bit. Backtrack by 38.
30 plus 9.
What are y'all looking at me for?
Okay, so 5. And then when you guys need to change something else. Almost there.
forgot a whole section.
He deleted the O.
I'm so confused. Were you trying to write a chart before?
Don't worry about it.
I don't know what I'm doing.
Trying to write a table. You had it correct.
Because I was writing like this.
Yeah.
This is bad.
I just went back to work before we did everything.
Alright, so how many oxygen?
I handed it to
Yeah, we just did it, we did it before, so.
You accidentally went with it.
14, right? Okay.
Yeah.
How many are here?
You're definitely
So, what do you need to add time?
What? Depth perception is all.
4 and 6. What number plus 9?
Wait, 7? What?
Oh, I
Even Tom. They're five.
Count the oxygen here.
That's still there.
Now,
Yes.
I'm kidding.
Yeah, we know.
is if you're talking about something in one spot and then
Calculate.
what would be
See
you always multiply the number in front multiplies the number outside the parentheses multiplies the inside the parentheses.
That would make a great document. It's all about
Could you write this out like before?
Yes. She did that with logs and math. She went 1 log, 2 log for her tree.
But there's 9
That's
here.
also what I don't like the log. It's like 1 log, 2 log.
I get like say
2 for one tree,
plus
1 for
9
one tree.
to the other
Or
side.
something like that.
one side.
I don't know why it was perfect.
I'm still trying to figure it out.
Do you need a chart? I don't know if mine's gonna be the best example.
Looks right.
Because 5 equals 14. Because, I don't know. Because this was,
Because I can't do math.
Twitter calculus?
Yeah.
We'll see. Miles are with.
Right there.
I'll teach you.
Okay.
It's the glare.
Is it correct?
I believe so, yes.
Promoted.
I mean, it's the numbers everybody else is getting, and it seems to be correct. I haven't actually done it yet. All right, ladies and gentlemen, let's go through this, and we'll work through it, and I'll show you the problem you run into and how you're going to fix it. Now, here is the good news. If you will keep working on these problems, they are guaranteed to work out for you. The problem is a lot of times people get frustrated, they get upset, and they're like, this is never going to work out, and they quit before they actually get to that final step where it does work out, and you're like, oh, okay, I get it. Okay? The method that you're going to use is going to be the same thing every time. I call it my scoreboard method. You can give it a different name if you want. You can do the I hate balancing equation methods. Whatever you want to call it, I don't care. Okay? But it amounts to this. I need to keep track of what I've got where, and I need to make sure that in the end, I have the same numbers on both sides. So, calcium, phosphorus, oxygen, silicone, and carbon. Those are the 5 different things that I have here in this reaction. 3 calciums over here. Okay? 2 phosphorus here because this 2 distributes out to both the phosphorus and the oxygen. There are 8 oxygens here. There are 2 oxygens here. That is a total of 10. There is 1 silicon here, and there is 1 carbon. What did I miss? It's a solid. It's supposed to be frozen. There you go. Sorry. Okay. On the product side now, 1 calcium here, 1 silicon here, 3 oxygens here, and 1 oxygen here for a total of 4. 1 carbon here, 1 phosphorus here. Okay, now you could start anywhere you want. The only place I wouldn't start with would be oxygen, because there's just too many of them to say, here's where I can put the number where I need it. So I'm going to start out with something that there's only one way to get it to balance, and that is calcium. There are 3 calcium on the reactant side here. I need 3 on the product side here, so I'm going to put a 3 in front of the CaSiO3. That changes the amount of calciums to 3, changes the amount of silicons to 3, changes the amount of oxygens to 9 here, plus the 1 here, meaning I now have 10. Questions? Again, I'm leaving oxygen. I'm not doing it until the end. So to balance off silicon, since I now have 3 on the product side, I'm going to put a 3 on the reactant side. That gets me to 3 of those. Now, instead of 2 of these, though, this gets me to 6. 6 here and 8 here is 14. By me writing these up above, ladies and gentlemen, I know when I have to change this by putting the 3 here, that I need to add it to somewhere else too. That is the reason that I put it up above. To remind me it's in 2 spots. To figure out how much you change each spot and then add it together. All right, so calcium balanced, silicon balanced, carbon balanced. Let's do phosphorus. I'll put a 2 in front there. Boom, that works out. That's balanced. Now, the only thing not balanced is the oxygens. That is it. Now, normally that would create a problem for us because carbon or oxygen is with carbon here. Well, a lot of times oxygen is going to be with something else. So I need to get oxygens balanced. So I have 14 here. I need to get 14 over here. The question you have to ask yourself is if there are 9 here, what number plus 9 will give me the 14 that I need? 5. I have to put a 5 in here. I can't not do that. I can't not get my oxygens balanced. So I'm going to put a 5 in there. That means that instead of 1 oxygens here, there are 5, which means I now have 14. But I also have 5 carbons. But here's the good news. Over on the other side, carbon was alone. I can put whatever number I want in front of it. So let me put a 5 here, and boom, this is balanced. It will work out every time. It has to. If it doesn't, I screwed up somehow. I gave you something that has a wrong formula. I've pretty much gone through most of the ones on this worksheet. There are no wrong formulas there. Sorry if you typos with that 2 being down and what looks like a number 1 instead of an L, but everything on there is good. It'll work out. Questions? What were the 2 types of reactions we talked about yesterday? Synthesis and decomposition. Today we got one more type. Today you need to take this out. Okay? If you don't have one of these, they're over there underneath the yellow periodic tables. Did you grab the pink one? The pink one. Go get the pink one.
I was just grabbing a blue one too.
You can't sit there. You can't sit. Seriously, you cannot sit. Get up there.
Why? Oh, I know.
Why?
Because I grabbed the wrong too quickly.
No.
Because I wasn't paying attention.
No. No. Because you just helped me demonstrate today's reaction. What? We switched places.
Oh my.
She used to have this desk. Now I took it. Okay, go ahead. You teach the class.
Balance the following chemical equation.
Let's switch back.
Okay? We literally just did a single replacement reaction, ladies and gentlemen. I literally replaced Nora in a compound. Now, the compound was her and her desk, but I literally replaced her with it. She therefore then had to leave, and she was without a desk. That is the single replacement reaction that we are going to talk about today, ladies and gentlemen. Single replacement reaction. You have 2 reactants and you have 2 products now. We can't say, okay, the side that there's no plus sign on. That was synthesis, that was decomposition. This isn't going to quite work that way, ladies and gentlemen. Sorry. Single replacement reaction is a reaction in which a single element takes the place of another element in a compound, creating a new element, or a different element, we should say, and a new compound. Nora and the desk represented the compound. I represented the lone element. I replaced her at her desk, making me and the desk the new compound, making Nora the new lone element. That is what a single replacement reaction is. A lone element is going to replace part of a compound. You are going to get a new compound, and you are going to get a new lone element. That is what single replacement is. Here's the general formula. A representing an element plus BC representing a compound will produce AC, a new compound, and B, a new lone element. So you need to look closely at what is involved. You need to look very closely at what the reactants are and what the products are. Was the example written down on your slide for you? That? Yes? Okay, good. So if you take zinc metal and put it with copper nitrate, the zinc metal will literally go in and kick out the copper nitrate. Or I'm sorry, will kick out the copper, making zinc nitrate and copper metal. Tell me the lab you did where you did this kind of reaction. Which lab in this class did you do that was exactly a single replacement reaction? Okay, you are on the right track. The blue water at first. And the what? The aluminum and the copper chloride lab. That was a single replacement reaction. The aluminum, when you stirred the copper chloride with it, broke down and went into the solution, kicking that copper out, that reddish kind of orangish color metal that then went and sat at the bottom of the container. That was a single replacement reaction. Okay? Now, how do you identify? You got to find an element and a compound on each side of the equation. You have to find an element and a compound on each side of the equation. So when you're done typing that, please take out your packet. We want to look at those first 20 again, and we want to see if we can find some single replacement reactions in that packet. So look through them. You need two things on each side. One has to be an element, one has to be a compound. And if you get an element and a compound on both sides, next to the number, put SR for single replacement, or you could put SD, single displacement. Replace and displace mean the same thing in the chemistry world. If you got one, tell me what number it is. 16. You are absolutely correct. Element, compound, compound, element. That is a single replacement reaction. Any others? 14. Element, compound, compound, element. It doesn't matter what order they're in, as long as on both sides of the equation we have an element and we have a compound. 14 is a single replacement reaction. Any others? 7. You know, normally we'd start at like the low numbers and work our way up, but that's okay. Compound, element, compound, element. Single replacement. Any others? 4? Well, we were going that way. We might as well continue, right? Element, compound, compound, element. Single replacement. Any others? 14, I think we mentioned that one, but let's double check. It's okay. You're going in the right order. Everybody else is going in the wrong. But yes, 14 was a single replacement. Any others that we missed? Okay. Now, because this reaction is so specific, ladies and gentlemen, I am going to be able to expect you to predict the products in this. Okay? I'm going to be able to ask you to predict the products. Not only am I going to ask you to predict the products, but first of all, got to figure out if the reaction actually happens. Because not every time you put a element with a compound will there be a reaction. Sometimes there will not be. Boy, it sure would be nice if there was a way of knowing. Oh, wait! Take out your pink sheet. Turn it to the side that says activity series of common metals. Oh, I knew you were going to do that. Okay, so here's the way this works, ladies and gentlemen. Okay, this is an activity series. The things at the top are more reactive than anything below them. So you may want to write, first of all, I would up at the top put single replacement reactions, because if you're looking at a single replacement reaction, this is the side of this pink sheet that you are going to use. So this is the side for single replacement reactions. Now, here's the way it works. You always have an element and you have a compound. Now, in your reaction, the way this is set up, these are all what kind of elements? So we are talking about a metal replacing another metal. Okay? So a metal is going to replace another metal. Now when it does, please remember, it may not be the same charge as the original metal. So therefore, when you write your compound, we still have to balance off charges. Okay? But we don't have to do anything if no reaction happens. If there's no reaction, you don't have to do anything except write the words no reaction and move on to the next problem. Now, how will you know if a reaction will occur? Well, what it amounts to is the activity of the two metals that are there in your reaction. The two metals that are there in your reaction. Okay? So let's take a look at the example that we had in the notes. That is right here. So we have zinc and we have copper. Those are our two metals here. Okay? Everybody see why? They're the two metals that are involved in this example. So now we find them on our activity series. All right? Here's zinc. Here's zinc. Here's copper. Zinc is more reactive. Why? Because we just said things at the top are more reactive, things at the bottom are less reactive, right? Might be a good note to put in there as well. Lithium, more reactive. Whatever's at the bottom, less reactive. So they're going in order. From the least reactive at the bottom to the most reactive at the top. So, when you look at it, which one is more reactive, zinc or copper? And it is alone here, right? It is not in the compound, correct? The more reactive metal will kick out a less reactive metal and take its place in a compound. So because zinc is more reactive than copper, this reaction actually happens. The more reactive metal kicks out the less reactive metal, and it becomes part of the compound. Okay? Now in this case, copper is a +2, zinc is a +2, so the formula doesn't change much. However, if copper had been a +1, this would have been CuNO3, no 2, and then this would have still been this way. Now we would have had to have balanced it. Okay? So the way we tell if a reaction actually occurs is if the more reactive metal starts out not in the compound. Okay? The more reactive metal has to not be in the compound. If the more reactive metal was in the compound, nothing would happen. A less reactive metal cannot kick out a more reactive one. Okay? So that is the entire way we base whether these reactions will occur or not. Okay? Entire way. So, this is an explanation of what I have just told you. Okay? It is in your notes. You don't have to look at it. You can if you want. The lone metal not in the compound must be more reactive than the metal in the compound. We do that by checking our activity series. If the lone metal is higher up, then it will replace the less active metal that is further down. If the lone metal is lower and the one in the compound is higher up, nothing will happen. There will be no reaction. Questions? Okay. So, find these two metals on your pink sheet and tell me which one is higher up. Find Fe and find Pb. Which one is higher up? So, will this reaction occur? Yes, it will. Does the reaction occur? Fe is higher up than Pb? So yes, it does. Now, we got to balance it. We got to balance it. Now that we know it actually occurs, we have to balance it. So to balance it, again, we need to make sure we have the same number of each thing on both sides of the equation. So, I had 2 NO3 groups over here. I had 3 NO3 groups over here. Here's a case of where iron is a +3, lead is a +2. So these formulas change slightly, right? Okay? But to balance off the 3 groups here and the 2 groups here, I had to get to how many groups on each side? What is the smallest common denominator of 2 and 3? What? 6. 6 is the least common multiple of those numbers, right? So to get to 6 NO3 groups over here, I had to put a 3 in front here. To get to 6 NO3 groups over here, I had to put a 2 in front there. Well, that also means I have 2 iron, so the 2 goes in front here. This means I had 3 lead, the 3 goes in front there. It is balanced. Questions? We'll give you a minute to practice these in just a minute. Just stay with me. Find silver, find magnesium on your activity series. Which one is higher up? So, does this reaction occur? No, it doesn't. Silver is lower than magnesium. So because of that, there is no reaction. So guess what? You're done. Right? No reaction and you're done. You don't have to balance it. You write down that this reaction does not happen. There is no reaction. Boom, you are finished. There's nothing else to do there. Questions? Find strontium, find sodium. Which one is higher up? Strontium. So since strontium is higher up, does this reaction happen? Yes, it does. Now you have to balance it. Okay? Now you have to balance it. Well, you have 1 strontium, 2 NAs, put a 2 in front here, and 1 SO4 and 1 SO4. And by the way, a little trick you can use when you balance these. Since SO4 is here and here, you could leave it together as a group if you wanted. You could leave that polyatomic together because in this reaction, it's staying together. It's up to you. You don't like that, you don't have to. Okay? You don't like that, you don't have to. All right, I think this is our last one. Aluminum metal is mixed with zinc chloride. Will this reaction occur? If so, write a balanced equation. All right. Now, you're not given anything here, right? Other than a word problem. So, let's take and let's make this into at least the start of an equation. Aluminum metal, how would I write that? Al is mixed with zinc chloride. ZnCl. You're close. 2. By the way, for this reaction to happen, your compound will always be aqueous. Your compound will always be aqueous. Now, before I go and write anything else, before I go and predict what the products will be, I need to know if this even happens. So what am I comparing? Okay, aluminum and zinc. Which one is more reactive? So is this reaction going to proceed? Okay, so now what I need to do is I need to write products where these two things are switching places. Okay? So that's the only possible thing that can happen here. These two are switching places, which means what's one of our products going to be? Zinc, Zn. Metal. Okay? That's one. What's the other product? How will I write that? Al Cl3. And because it's a compound, it is going to be aqueous. This is always what your single replacement reactions will look like. The only exception would be if instead of this being zinc or that, this could be hydrogen. Now, if it were hydrogen, what would I have to do to it here?
Two.
I'd have to put a 2 by it. And hydrogen is not a metal, is it? But what state would H2 be in? State of matter. It's a gas. It's a gas. Okay? It's a gas. All right. What is the last step that I have to do with this problem, ladies and gentlemen? I got to balance it. I got to balance it. Okay. Now, ZnAlCl. 1 zinc, 1 zinc, 1 aluminum, 1 aluminum, 3 chlorines, 2 over here. Now, I haven't shown you this trick before, but when you have an element and there is 2 on one side and 3 on the other, how many do you have to get to? No, you can't. You can't get this side to 3. So you have to get to 6. 6 is the least common multiple of this 3 and 2. And because it's only in one place here, chlorine here and chlorine over there, I got to get to 6 of them. I got to. So the side that has the 3 or the 2, I put a 3 as the coefficient. Gives me 6, gives me 3. The side where there's a 3 as the subscript, I put a 2 in front, 6, 2, and now I finish balancing by putting the 2 in front of the aluminum here, the 3 in front of the zinc here. Boom, you've got it balanced. These are not difficult to balance normally. Single replacements are normally fairly easy. Questions? Okay. This is the worksheet, ladies and gentlemen. This is in the worksheet. This is on the page is titled Predicting Single Replacement Reactions. Okay? So, let's work through a couple of these together and then I'll let you go at them on your own. Okay? All right. So, there we go. There we go. All right. So, for this first reaction, what 2 metals are we comparing on our pink sheet? Zinc and... Life is going to get easier if you start learning some of these symbols. Tin. Tin. All right, so find me zinc and find me tin on your sheet. Which one is higher up? So is this reaction going to happen? It is going to happen, which means that this zinc has to replace the tin in the compound. Okay? So, zinc is going to go over and replace the tin. What is the charge on zinc? Try again. You sure? See, now we're guessing. Now we're just being silly. Again, we're going to double down on being wrong here. You know what? I'm wrong, but I'm going to stick to it. What is the charge of zinc, please? It's written by zinc on your periodic table. +2. Good, thank you. Now what's the charge of NO3?
1. -1.
So what would the compound look like? Zn, parentheses NO3, 2. What would I put by it for a state of matter? A what? AQ. Thank you. Okay, what would be the other product? By the way, what's the charge of tin here? Nope. What's the charge of tin here? Let me ask the question. What was the charge of zinc over here? None. When things are alone, when things are elemental, they have no charge. The only way this zinc gets a charge is if it gets near the nitrate and then it can give it electrons. So it'll give it 2 electrons. The zinc will become positively charged now. The nitrate will become negatively charged and they will be attracted. But over here alone has no charge. Has no charge. Okay? So what charge does our tin have over here? 0. No charge. It's alone. It cannot have lost or gained electrons because it isn't with anything. So now, put an M by the metal. All right, what do we do to balance this? Nothing. It's already balanced. 1 zinc, 1 zinc, 1 tin, 1 tin, 2 NO3 groups, 2 NO3 groups, you're done. You've actually balanced it. Nice job. Didn't even know you did it. Questions? All right. Now, one thing I would like to point out to you. In these reactions, okay, if I give you a metal that we cannot find its charge on the periodic table, I may have to tell you in the problem what charge the metal will be when it is in a compound. So I may have to tell you that, the tin would be a +1 or a +2 or a +4 in the compound. And I will tell you that in the problem if we need to. Okay? So I'll show you one like that in a little bit. All right. Problem number 2. Aluminum is mixed with nickel sulfide. Nickel 2 sulfide. Is a reaction going to happen here? Why? Aluminum is higher up or more reactive on the reactivity series. Okay, so what does that mean for our first product? What's it going to be? Like that? Where do you want a 3? Okay, let's go back. How do we write a good formula? I need to know the symbol and the charge, correct? So what's the charge for aluminum when it is in a compound? +3. What is the charge for sulfur in a compound? -2. So what does that mean for our formula? Okay, so what does it become? Al2S3. Going to get rid of these numbers up above because we don't write them there anymore. Okay? What do I put for state of matter? AQ. Okay, then what's my other product? Okay. Now, do I got to balance this? I do. AlSN. 1 Al, 2 over here. 1 S, 3 over here. 1 nickel, sorry, that should be Ni. 1 over here. What do you want to do to balance? Where do you want to start with? Okay. Which side needs more? So what number do you want to put in front of the sulfur compound on the reactant side? Now what?
Change aluminum to 2 on the reactant side.
Put a 2 in front of aluminum on the reactant side. Put a 3 in front of nickel on the product side. If you do your formulas right, everything will work out every time, ladies and gentlemen. Questions? Okay. You've got 3, 4, 5, 6, 7, 8 more to do. Go to work, ladies and gentlemen. Another thing crossed off our list, being able to write single replacement reactions. Hey, did I mention you got a quiz tomorrow? Okay, you got a quiz tomorrow. You need to balance 3 equations and you need to tell me the parts of a chemical reaction. Valeria, what can I do for you? Again? Again? Didn't you use the bathroom yesterday? All day you didn't use the bathroom. You expect me to believe that. All right, then I guess you get to go today.
And then I need a new packet because I left the one I have at home.
Here you go. You're welcome.
I wish you could like